Okay. Never really been introduced before. I should get like walk-up music or something like that. You can ask me later what my walk-up music song would be. Yes, as we know, we're talking about microservices and CICD. I'm going to talk a lot about service mesh. Really, hopefully at the beginning, I'll just be introducing some of the open source tools that I'm going to use in this demo. And most of the time, I'll hopefully be doing demos. I like live demos, so we'll be doing demos live here. Just a quick note on who I am. My name is Brian Redmond. I work at Microsoft. I've been at Microsoft for over 19 years, which is kind of amazing. My last name's Redmond. I don't live in Redmond. I've visited there many times, but that's been my name since the beginning. I'm a program manager on our global customer success team. I work with our field to help enable them to bring customers to our Azure cloud platform, and primarily around open source solutions like Kubernetes. I recently moved to Denver, Colorado, and by recently, like 5 days ago. So I'm pretty excited to be there. Obviously, there's other big Denver fans here. But yeah, I've lived in Pittsburgh for most of my adult life, so I'm excited to be there. I like to be outside, so it's a perfect place to do that. And this is a picture of my wife and I in Hawaii. It kind of looks like we've jumped out of a plane with no parachute. I don't recommend that. So let's get started. Let's talk about microservices. So I saw this on Twitter. This is from a company, Monzo. They do online banking out of the UK, I think. And this is something they tweeted. They said they had 1,500 microservices. And this picture kind of showed the network rules and policies between each of the microservices. And it was a interesting thread, honestly. People had sort of almost violent reactions to it. Like, this is ridiculous. There's no way you could manage that many microservices. And others thought, maybe this is super impressive. I'll be honest with you, I've talked to folks from Monzo at a previous KubeCon, and perhaps someone is actually here at the conference. But what they told me was it wasn't easy to get to the point where they could have the tools and processes in place, the organizational change to manage microservices at scale. But really, honestly, once they got good at it for even a small number of services, like 50 or so, 1,500 wasn't any more difficult. It could be honestly hard to get to that stage, but once you get good at it, it's not that much harder to multiply at times a big number. 1,500, I would say, is a big number. But some companies certainly give up. This company, they were called Segment. They posted a blog, again, something that I saw on Twitter. And they were moving to microservices, and they struggled with it. And they essentially went back to a monolith. I love how they call it a superstar. I think that's a great name. Obviously, monolith just sounds negative, so they went with superstar. And so they went in that direction. I'm not really here to kind of recommend microservices or not, and the journey that you should take in that. It's just if you go down a path of microservices, you're probably going to need better procedures and things to do automation around that. And certainly one of the things that you'll need is testing. You'll need a lot of other things, but you'll need testing. I, of course, have to have Clippy because I work at Microsoft. That's required. But you'll need testing. And testing means a lot of different things. When we say testing in production, it's a little bit of a joke. We obviously see the entire thing catching on fire. But honestly, we do actually need to test in production. I'll talk through some of the ways that you would do that, but honestly, at some point you're going to roll out your new code into production. And even if you've tested it in a lot of different environments with a lot of different transactions, that first time you run it in production, that's also a test. And so the more that you can actually get test results in that production environment with production data, the more successful you'll be. And certainly I'll talk through some of these strategies pretty quickly. I would imagine this audience is pretty familiar with these things. A blue-green test. I put the new version in the production environment. I run some tests against it. Once I'm comfortable with it, I just use some kind of proxy and cut over to the new version. Pretty simple to do that. The Canary test is where we do the same thing. We run version 2 in that production environment, but we start to just funnel some of the actual user traffic over to it by percent. We start very small, maybe 5 or 10%, and we slowly ramp up as we meet the thresholds in our testing that we need until the point where we just cut it over and we're using the new version. Easy enough. There's also strategies like A/B testing, where we actually mirror all of the traffic that we're getting through our production system to our current version as well as the new version and validate it against it. We may actually store some of that in a separate database, a different backend database, of course, because these are real transactions. But we get a real picture of not only how does it run in the production environment, but how does it run with our real customer traffic. And this is super powerful. The hard part, of course, is I've got to have capacity to run double the transactions, which could be costly, could affect the production traffic, not necessarily easy to do, but certainly effective if you want the results. So what we end up with is, in a microservices world, having to do that at scale. We don't just have to have one service, blue-green at a time. We've got a bunch of services. And if it's 1,500, I've got to do this in a pretty efficient way. It has to be automated. I need something to help me with that. And that's really where the concept of service mesh comes in. And so service mesh, of course, solves everything. We all know this. We've probably seen this cartoon. I love it. I think it's fake, frankly, but probably pretty realistic, right? We've all been in those meetings where people just say, well, service mesh will solve it. And I'm a big fan of service mesh. Trust me, I'm in the service mesh track, so I must be. But there's certainly many places where service mesh doesn't make sense. So I think that's probably the mistake some folks make, even with Kubernetes or service mesh, is just applying it to everything. That obviously it's good technology, so let's use it everywhere for even we're not actually trying to solve specific problems. So with that, I like to always quote William Morgan when I talk about service mesh. William's from Buoyant. I like to credit them as the sort of founders of service mesh. And he defined it as a dedicated infrastructure layer for making service-to-service communication safe, fast, and reliable. And I think that's a pretty fair description. When we say safe, fast, and reliable, we're getting some of these kinds of things. We get some observability about what's going on. Again, 1,500 microservices. What's the latency between a bunch of those or a single transaction through that? We need to have that information. I'm going to talk a bit about traffic shaping today in the demo. That's how we're going to do our Canary deploy. And so I'll probably mostly focus on those first couple, but you can certainly do a lot more with a service mesh platform. I do want to point out as well another quote. I'm obviously saying too much about Buoyant. I've been accused of working at Buoyant. I've never been paid by Buoyant. I just happen to like the technology. But William wrote another blog, and he put this in there. I thought this was super interesting. It gives you the features that are critical for running modern server-side software in a way that's uniform across your stack, and it's decoupled from the application code. Because really doing these things on the left-hand of the slide, you can do it any way. There's tons of ways to accomplish those things. It's fairly straightforward. It's these factors that actually make service mesh interesting. I don't want to have to affect the code. I don't want to build these into the code and the applications themselves. I don't want to ask developers to have to learn this across a diverse set of programming stacks and things like that. And so that's why I come to service mesh, and you can obviously pick any one of these kinds of tools when you want to do something with service mesh. If you've been here all week, obviously you've had lots of opportunities to learn about these tools. Again, I'm a fan of Linkerd. There's, again, quotes out on Twitter that you'll see out there. Justin Davies, a friend of mine that is out of the UK. I think there's a common reaction. You set it up, and you're like, well, obviously this didn't work, because it couldn't have just worked the first try. With like three commands, it's set up and running, and it's giving me results immediately. And so obviously it must have been broken or something. So it's super easy to use, and you get good information out of it very quickly. And so I'm a big fan of it, and that's one of the things that I'll be using in the demo here today. The architecture, again, I think we've been talking about service mesh for quite some time. I'm not going to spend a lot of time on it. If you're new to the topic, in the data plane in your actual application pods in your cluster, that's where the sidecar Linkerd proxy will sit. And so you'll see 2 containers running in every pod that's meshed, and all of the traffic goes in and out of the proxy. It's all managed by that control plane. So that's actually where we configure the service mesh, and we get information about observability and all that kind of stuff. So I'm going to use another open source tool in this demo called Flagger. So Flagger came out of an open source project that came out of some folks at Weaveworks, and obviously they're one of the sponsors here at the event. And really what this was about was to provide some kind of automation to be able to deliver a Canary test for a particular deployment. So actually do some of the traffic shaping rules to slowly drift some of the traffic to the new version, perform some of the acceptance testing, work through in that workflow according to your configuration until slowly it's actually cut over and running in the new version. And so it's pretty powerful in what you can do there. I still would consider it a fairly young open source project, but you'll see how it works when we go through the demo here. The other thing that I'm going to take advantage of here is something called Service Mesh Interface. So this is another open source project that's super helpful when we talk about something like a tool called Flagger. Flagger, if it's doing some of that traffic shaping and they're working with the many different service mesh solutions that are out there, they've got to actually build their system against all of those different service mesh platforms. It would be great if they had a standardized way to actually talk to those service meshes. And that's really what Service Mesh Interface is about. It gives you this standardized way to represent service mesh configurations, but not necessarily have to understand the underlying mesh. And certainly, again, when I'm doing things like a Canary test, it's pretty straightforward that I just want to route some of the traffic over to one particular version and maybe some to the other. And so I can just build in a standard way to do it that's pretty simple and not necessarily have to learn all of the configurations of that underlying mesh. And so we're going to see that in action again with the traffic shaping. It's not really a new concept in Kubernetes. We obviously see this with the Ingress controller. And so you put Ingress objects into your Kubernetes cluster for network routing. The actual Ingress controller under the covers doesn't really change that much about the Ingress. Obviously, we all know there's little nuances in that. But certainly, it's the same idea with Service Mesh Interface. In these early stages of SMI, right now we have traffic split that, again, I'm going to show you. We have traffic metrics and also traffic access control, doing policy around service-to-service communication. A lot of folks actually worked on this. So we've had a number of different companies, including Microsoft, that worked on building SMI. And again, it's in its early stages. I think it was announced at the last KubeCon. So certainly a lot of opportunity to get involved in this and expand upon the work and take it to really cover, I think, more scenarios that Service Mesh actually works in. So that's the different tools that I'll be using in the demo. So of course, I like to do live demos. So that's my preference. Who knows if it'll work? I actually went in and took a look at my cluster right before the talk, and my Nginx Ingress controller had like 1,012 restarts or something. So those are those fun moments. But if it's not live, I'm not a fan of doing it. So let's jump in and take a look. Actually, I want to show you real quick what this application looks like. I use this application a lot as a demo application. Essentially, we store geospatial data in a database on the back end. We display it on a map, and we have a bunch of microservices in the middle to retrieve that and pull that back. It's just for the purposes of demos. That's why we have a bunch of extra microservices here, so that we can experiment with things like we're going to do today. But you'll see it kind of how it works in action. For the demo, we're going to take this Flights API, and we're going to do essentially a CICD deploy and a Canary test, as I've been describing. All right, so that's what it'll look like. Let me jump over to my demo here. This is what the application looks like. So I mentioned that we have these different microservices. Each one kind of returns different data here. So again, we're going to be talking to the Flights microservice. It's the one that when we click on this map, it brings back all of the data. And this is actually just a quick look at when you call the status endpoint on this. You get back some results on what version you're talking to. And so that'll actually help us kind of see, as we do this Canary deploy, what version we're talking to. And I'm going through the Ingress controller here to get that. We're using GitHub Actions to do the CI/CD. So I'll show you how this works here once I get into it. And over in the cluster, this is how the application looks when it's deployed. If you can't see this, you probably need to move closer. I stood in the back, and I could make out basically half of it, and most of it was from memory. So we have a series of deployments that represent each of those microservices in the front end, obviously all the pods that are with it. A couple of interesting things to point out. One is I have this load tester deployment. That's not really doing anything at the moment. It's sitting and waiting to be a part of this Canary test. So when the Canary test kicks off, it actually can call into this load tester to generate some traffic. Because obviously, if we're going to measure the Canary deploy, we've got to make sure that it actually has traffic, so we have something to measure. And maybe our users aren't active when this is actually running, so we need this to actually be a part of the test. And I'll show you how I configure how that actually works when it happens. The other thing is, notice I have the primary deploy here, but I also have this other deployment that doesn't have any pods running. So that's actually where the Canary will end up appearing. The other thing is I have services that represent each of these. So I have one for the Canary and primary specifically in case I want to call them specifically. And then I have Flights API and that's the one that's associated with my traffic split SMI. So when I call Flights API, the traffic split, as long as it's working with Linkerd and not unmeshed, will take advantage of that and actually follow the rules of this traffic split. And just real quick, so you can see what this looks like. You can hear my Mac keyboard. Everybody loves that. And you can see down at the bottom, we're sending 100% of the traffic to the primary and none to the Canary. This is what Flagger will do for us as it kind of moves that forward. All right? So what I'm going to do is actually quickly go in and make an update to my code. I've got a couple different workflows that I want to show you in GitHub Actions. So a part of our CICD here, we're going to do a pull request workflow and then a complete CICD workflow. So first, let me just show you what the pull request looks like. I'm going to make an update to the app. I am in my KubeCon branch here. Make sure I'm in the right branch. And we're just going to change that version. Not very exciting change. I'm sure there's much more interesting work that I've done in this branch. And we're going to do a pull request, and I'm going to let you see, get this started, and then I'll show you actually what's happening in the background. And I do want to make it against my fork, and I do pull request. I do already have a pull request sitting here, and that's just for the purposes of speeding up the demo. But the pull request workflow, in my case, this isn't the test in production Canary part of the test. This is just, I'm going to take this pull request and perform some kind of acceptance testing against it. In my case, I'm actually just going to do a container image security scan on it. I would imagine there's a lot of other things that you would do here, but I end up just going through the steps here, doing a Docker build. I'm using another open source tool called Anchor here. Really not important of what's actually happening here. It's just that this is a part of my workflow that before I actually am even doing this Canary test, I'm doing a series of tests only against the pull request itself. All right? And you can see results of this over here in Actions. The current one should be running. It actually isn't, funny enough. Did I not complete my pull request? We'll ignore that. But what I want to show you on one of these that ran, when I first actually set this up, I had a failure of one here. And so you can actually see the Anchor scan fail. And funny enough, this is code that we use all the time in workshops and demos. And I actually had two high security vulnerability CVEs in this. So it was kind of funny. I actually had to go fix it. And it turned out it was some random package that was a part of this Docker image causing this problem. So again, before I've actually pushed this into production, I perform a series of tests. Once I'm comfortable with it, I go to my pull requests, and I'm going to merge one of these. I'm going to take the one that I did here before. Oh, I love how it moves you back to the... It always wants to take you back to the original repo. So you can see this is one that I did earlier today. I did a pull request just like we did before. I upgraded to version 1.30. In fact, you can see when I say show all checks, this is where that security scan occurred. I've got some folks on the team working with me. Joey checked in his code so we can merge this pull request. So since that's being merged into master, I'm going to show you actually what that workflow looks like. So in this one, I've got a series of messages that are writing this info out to Slack. So we'll see Slack messages come up kind of here as we go. But basically, I'm logging in. I'm using some tools in Azure to actually create my container image in Azure Container Registry. And then I'll connect over to my AKS cluster. I'll set context, and then I will set the image deployment for this new image that we just built. And so this is kicking off and running right now. But the important thing is, even though I set this new image tag, it's not just going to automatically update that Flights API. This is where Flagger is going to step in, intercept this, and kick off my Canary tests. And it'll take it a second to get going here. Let's actually see if something's actually happening. Thankfully, it is. And shortly after it does a checkout, we'll actually see messages kick off. Our CICD workflow has started. I want to jump over here to this environment and show you what's actually going to happen. So you can see down here I have this Canary object called Flights API down here at the bottom. This is the Flagger CRD that actually drives what this Canary test will look like. And over in my repo, I have got that object for you to take a look. And so again, it has an object called Canary. I can specify the deployment that I want to run this against, so obviously I could have multiples of these. And then this is where I actually configure the actual details of how I want this Canary test to run. I can set some different thresholds. I can say start at this percent and increment X number of percent. I can control all of those details of how I want this to occur. And so a lot of other steps in there. I would imagine there might be even more customization folks want to do, and I think that's the kind of thing that as this project grows, you'll see those things come in. The testing, I love how it says optional, not optional. But certainly there's two kinds of tests that you'd run when you kick this thing off. And by the way, let's just look and see, is it kicked off yet? Not quite. The first one is the pre-rollout. Did this thing actually start? Is it actually just working? Is it running at all? And so in my case, I'm just hitting that status endpoint and making sure it actually returns some information. But certainly once I know that it's past that acceptance test, this is where we use that load tester pod running in the cluster. And it goes through and uses this Hey tool to generate traffic against this Canary to make sure it's actually working. And so we'll see traffic funneled here, making sure that this is actually working as expected. And then Flagger will go through and increment and slowly perform this test for us. Let's see where we are. You can see it actually kicked off the test here. And so it's saying that it's sending some of the traffic over to the Canary. So let's go over to the Linkerd dashboard and see what's going on here. One thing that's cool is we still see 100 at the primary. Fun enough. It's progressing. It's getting there. One thing that's cool about Linkerd is it actually natively uses the traffic split API as a part of the service mesh interface. And so you'll see, we already see it switching over to sending 10% of the traffic to the Canary. It's natively using that traffic split that we saw earlier. So when we go back over here and we take a look at that same object again, we see it's now 10 and 90. That's exactly where Linkerd is actually getting its metrics here. So we're seeing this now start to funnel some of the traffic over to the Canary, and it's performing some of these tests. If we go take a look at the deployments, we can actually start to see that traffic is actually appearing here, and we'll actually see test results from this and know that we're actually seeing success. Now, while we're waiting for that, I did want to show you some of the other interesting things you can get out of Linkerd. Again, we obviously are measuring a lot of statistics on how this is working, but what about what API calls we're actually seeing results against? A lot of times when we're troubleshooting a problem with a particular application, we know that it's performing slowly, but where in the code is the problem? And so Linkerd actually helps us with this. If we actually take this tool called Top, and it's using all the data that it's collecting inside of Linkerd's Prometheus backend, and you can see a bunch of the results of the actual calls that are coming in through the service mesh. And if you notice, it actually is down to per API path measurements of what's actually happening. So now I can actually see where's the worst case latency for all of the calls that are coming through this particular service. And maybe I can actually understand that this get latest flights is the slowest one. And maybe I even see a number of errors or issues in there. Now I know exactly in my code where I need to go troubleshoot and address that issue, which is pretty cool. If we go back over to Slack, we'll eventually see this thing kind of finish. It looks like we're at the 40% stage. The way I've configured this, if we make it to 50 and it passes all of the tests, it'll actually go and roll out the new version. If you take a look in the cluster here, notice that we have the two primary pods that are running, and then that other one that's not primary is the Canary pod that's actually running. And again, this should pass. It's possible that it won't. But certainly in my experience running this, it usually works. So that is how that part works. I did want to point out one thing that I think is really, really interesting from this. Because I'm using a few different tools, it's actually hard for me to go back in and troubleshoot this CICD process. So as much as I think this is interesting from a demo point of view, I have a Slack tool where I can go in and get monitoring of the results of things while they're happening. But it's a bit harder for me to actually understand, okay, this thing failed. I've got to go to GitHub Actions over here to troubleshoot this part of the process. I've got to look inside of Flagger to actually understand what's happening in Flagger. Like, for example, if I want to know what happened with Flagger, I do a describe. Oops. How many times am I going to forget the namespace? So we see this result here of what actually happened. You can see it's doing that, it's doing its finalizing and updating and actually accepting this new version and rolling it out. But I'm looking here for this part of the troubleshooting and another tool for another. So not necessarily ideal, but the point being that we understand kind of having that ability to kind of go through each step of the process to roll out and go through there. Make sense? All right, awesome. It went actually fairly fast, which leaves me a bunch of extra time for questions. So I will take questions. And again, there's a microphone there. And certainly happy to have, Karen says she's willing to run around and take questions. So I can't tell if they're going to ask a question. Certainly happy to answer more questions after the fact. This guy here has a question.
How about there? That sounds good. Hi, Brian. Scott Fulton from ZDNet. You mentioned how Linkerd is your service mesh of choice, but based on the structure of the demo you just presented, can any other service mesh work in its place? And if it does, is it more difficult? Is it easier in certain areas? Are there advantages and disadvantages?
Yeah, it's a great question. We do get that question a lot. Like in the purposes of that demo, because I use service mesh interface, which again I'm a big fan of, it would be very easy to swap that out. And that, especially using the traffic split API, you could swap out which service mesh you're using, and the demo would work exactly the same with almost no changes. Part of the value of that too is, again, because I'm using SMI, the Flagger project can more easily adapt itself to the different meshes because it's just taking advantage of service mesh interface in that standard way. Now, the other part of the question that's maybe different than the demo is, almost like, why would I pick a particular service mesh over the other? And to me, it comes down to just looking through the requirements of what you're trying to accomplish. They eventually, I honestly think they'll all have the same feature set. And so then it will really just come down to maybe performance testing and understanding what vendor you want to work with and things like that. And the early stages, there's still some feature differences between them. The number one thing I would look at, the very first thing I would evaluate if I was trying to pick one is from a performance standpoint. I'm gonna test my application rigorously without a service mesh, maybe mesh the application and find out the overhead of that platform. As we know, there's overhead. I mean, there has to be. Is it measured in tiny milliseconds, or is it measured in something horribly much bigger? And also, how does my cluster run? Is it taking up a bunch of cluster resources and so forth? And I do believe at this stage, some of the different service meshes have advantages over others in particular areas. But again, I think in the longer term, that won't be the deciding factor. There's a question over there.
For the acceptance tests for the Canary group, if I'm using the right word group, so let's say it's moving in 5 pods at a time. When it sends the test, is it going to every pod in the group, or is it sending it through the ingress and it just gets some set of them?
It's a great question, yeah. If you had a lot of replicas, you'd want it to test maybe multiples of them. I would hope that would be configurable. My impression is it just hits the service endpoint. So at that point, it's going to sort of randomly get one of them. And if that's configurable, I don't know. If that's something you can say, I want to hit that acceptance test 5 times, 20 times, and validate all of them, and that way you'd hit all of the pods. I don't know enough about Flagger if that's true, but I would think in the longer term that's easy to implement. And again, it's open source, so jump in and contribute. That's always the answer, right? There's a question there.
Yo. In Flagger there, you did that hey little line to test the deployment. Does it use actual traffic, like outside traffic in its decision making before switching over, or is it only using the hey, what's up thing?
That's great. Yeah, great question. And it's both. So it's measuring everything, But the reason it's using Hey, and again, Hey is just part of the sample that they provide. You can honestly use anything you want here. But let's say you didn't have enough real traffic coming into your application, users were asleep or whatever that may be. This is one way to drive some traffic to do some measurement. In a much busier application that's typically busy 24/7, you may not even need to run this part. You may just have real user traffic. Because again, the point of the Canary deploy is getting real user data through there. And so ideally, you don't need Hey. And so I don't know if that's what's behind your question, but to me, that's how I think of it.
I could omit that whole statement there, that whole line, and just let it run against production traffic or whatever.
Yeah, you don't have to have it, and perhaps that's why they say optional there.
Yeah, okay.
But yeah, certainly from a demo standpoint, I needed it. But yeah, that might just depend on your situation. And it's nice that you can control and implement those pieces. Yep.
Thank you.
Yeah, go ahead.
Hi there. I'm just curious about how I saw you had 0% and 100% on your primary or your Canary versus primary respectively, and then you slowly worked that up to 10 and then 20, and then I saw 50%. So is that configurable, and is it just based on the amount of time that's passed? Is it something you can control directly? What was your strategy for that?
It's right here in this Canary object, in the actual Flagger Canary object. All of that is configurable. Now, I just decided, again, somewhat from the flow of the demo, to make sure it was started at 10 and stopped at 50. I don't know that that's my advice on the proper way to do a Canary test. But at the same time, you can set all of that you want. You can see the intervals controllable. Every 30 seconds go up. I would imagine in a production scenario, you wouldn't just be fire through there every 30 seconds. So you kind of have to have a feeling of how your application works and what you would do there. But a good bit of it's configurable. And honestly, I wouldn't be surprised if there's more configuration options than what I have listed here, or if there are more coming as they kind of walk through working towards kind of a version 1 release of a tool like this.
Yeah, because I can imagine something along the lines of, okay, we want it to be active for a certain amount of time before doing that. And if that would be configurable, then that would be nice. I'm still new to all this, but it's very interesting how that happened.
Yeah,
so.
yeah, I agree, and I think that this kind of tool sort of does it a certain way, and that's an advantage because I can just take advantage of the tool and I can create this Canary object and I can make it a part of a Git repo and follow it that way. But if I need to really truly have a ton of control and customization, then I'm going to script the entire thing, which involves a bit more work and management, and maybe that's not ideal. But if you really need that kind of control, then you have to do it that way. That's probably the way most people do it now. They build something into their CI/CD system. This is just doing some of the work for me.
Thanks.
Mm-hmm. Well, with that, I'll wrap up. I can take. Oh wait, we got one more
really
question.
Quick.
And then we'll wrap up.
This is the first time I've seen SMI in action, and that was kind of neat. Is this available somewhere? Everything you showed, so I can just steal it from you and use it at work and get a raise and shit.
Yeah. Absolutely. I put the link in the slides, but I have a series of SMI demos. And so everything that I kind of did here, with probably more than that, is somewhat the instructions are listed here. I wouldn't call this instructions you could just take and follow, but you could probably get a good bit of it working. To be honest, if you just went to Flagger's walkthrough here, you could actually see how a lot of it works with their pod info sort of sample application and get everything set up and running.
Okay. And they talk about SMI as well?
Yeah, SMI is listed there. They use the SMI in this demo.
Nice.
But certainly you can go to the SMI website and see some samples of more than just doing traffic shaping and so forth. So.
Thank you.
So with that, I'll wrap up. I'll certainly take questions up here kind of as we go, but I appreciate everybody joining. And yeah, only a couple sessions left, but enjoy what's left of the conference. Yeah, thanks.